Today our focus is going to be on pointers. We're going to do pointers in C++. Now we start with the formal definition of a pointer. What is a pointer? So a pointer, first of all, a pointer is a variable. Okay, a pointer is a variable. That's an important statement. That's an important thing to know. A pointer is a variable, but it's a variable that stores a memory address of another variable. So that's very important. I just want to do a quick demonstration. We can think of memory. In memory, we have, it's like blocks of memory. So in computer memory, we have something like blocks of memory, and each block has its own address. This is by default. So your computer will be having this memory and it will be having its address. For example, this first block here, it will be having its address that starts with 0xE and some numbers. So that's its address. Okay, so it's an address of this block, and so each memory in computer has its address. So this is an address of that block, and you can also have other boxes that have their own addresses as well. Now we say a pointer is a variable that is going to store an address of another variable. So we want to explain that. We want to visualize that and see what we are talking about. So I'm trying to do just that. Okay, so I'm going to copy this address so that because each memory has its own address and different addresses. Okay, so this one let's make to be EXE5. So addresses, because addresses are like that. Usually, if you print an address, you'll see something that's going to start with OX something. Now we say a formal definition: a pointer is a variable that stores the memory address of another variable. Now, when you declare a variable in your program, the computer is going to choose. It has memory. There is a memory available, and there's memory available that it can choose from. So this is a memory that is available that the computer can choose from. And by default, each memory block in your computer has its address. Now, when you declare a variable, you're going to state its data type and the name. So this is what happens. So when you declare a variable, say you declare a variable, you say, let's say you're going to say int, num. So you have declared a variable. You are telling your computer to reserve memory where you're going to store an integer variable. Okay. So what happens is that the computer is going to take it's going to choose randomly. It's going to choose randomly from this available blocks, and it's going to give one of these blocks a name that you have declared when you declare a variable. So let's say it's going to choose this block. Let's say it's going to choose this block here. So it's going to give it num, which is the name that you have declared. So it's going to give it the name that you have declared, which is now. So now this memory block is named now. Now remember, each memory block by default has its address. Okay, by default, each memory address has its address. So now this memory, when you declare an array, this memory now no longer has only an address, but it also has a name that you have given to it. Okay, so this is what happens when you declare a variable. A computer has a vast amount of memory that it can randomly choose from. So it's going to choose which one to reserve, and it's going to reserve this one. It's going to give it a name, but by default, each memory block or each memory that's available in your computer has an address. Now, when you give it a name, it no longer only has an address, but it also has a name now. So we say there is also another type of a variable that's called a pointer variable. This one specializes in storing only the memory addresses of other variables. So if we want to store the memory address of num, which is this one here, we'll need to declare what we call a pointer variable. So a pointer variable will be holding the memory address of num. So num is a variable, and a variable is nothing but a named memory location in a computer. So if you want to store an address of that memory location, then you'll need to declare a pointer variable. Now, how do we declare a pointer variable? Here is a syntax. You first need to declare the data type and the pointer name. By data type, we are saying, okay, if you want to store an address of a variable data type, for example, num is int, and we want to store an address, we want a pointer that is going to store an address of num. Since num is int, also the pointer should be int. But when we declare a pointer to specify that it's a pointer, we use this asterisk here, this small star here. So you write the data type, then the pointer name. So you show that this is a pointer. This asterisk here shows that this is not a normal variable, it's a pointer variable. And it can only store addresses, not values. It doesn't store values, it only stores addresses. I hope that part is clear. So it will also get clearer as we continue. Now we continue. So here we have now we have a simplified explanation of what we are talking about. So we say normally normal variables, so they store values. A pointer stores the location of the value in memory. For example, you have variable num here that is going to store maybe 5. So you have this value stored in this memory location. It has a name, which is num. So you use a normal variable, which is num. Num is a normal variable that has this value in it. But also, by default, each memory has an address. So you can declare a pointer that is going to hold an address to where this value is stored. Okay. So now we have an example of a code down here. So we have an example of a code. We have int x. X is a normal variable. Okay, x is a normal variable, and it's storing 10. Now we declare a pointer which is going to hold an address of x. Now we say int, then the asterisk, that star here, to show that now we are declaring a pointer. So you're saying this is a special variable. It's a special variable which is a pointer. It's not a normal variable. Now, since a pointer can only store an address, we are going to use this symbol here to get an address of x. So we want to get an address of x. So this is an important part. So now if you want to get an address of, let's go back to our example here. Let's say we have num here. So how do we get an address of num? For example, let's say you want to print out the address of num. You want to see what's the address of num. Now this is a code that you would write. You would write this code, you would say cout, and you have that. So you use, I'm going to write it in bold, this operator, so that you can see. Yes, you use that operator in order to get an address of a variable. You use it, then you write the name of the variable that you want to get its address. So we want to get an address of num now. Now that is going to give us the value of the address of num. And given our example here, the address of num, meaning the output is, we are expecting the output to be OXE6, which is going to be OXE6 according to our example here, because we said the memory address of this block here that we have given the name 5, that we given the name num is this one. So this is what we're expecting to get. Now you can also use this, but instead of printing out, you store it in a variable, and the only variable that can store that address is a pointer variable, because it's the one that is designed for storing memory addresses. That is why we do this. So here PTR is the name of our pointer that is going to hold an address of x, because we know this operator is going to get us the address of x, meaning what we are having now here, we are declaring a pointer variable ptr, then inside it we store the address of x. Okay, now we break down this code down here. So we're going to break down this code so we understand it here. So this part here, the operator and the variable, they give us the address of X, which is our variable. And then PTR here is going to hold that address. It's going to hold that address. And also when you want to get, so let's go back to our example. Now, when you have a pointer and a variable, if you have a variable, meaning that means it's a name of a variable is the name of your memory location that you have reserved, okay? And we know how we get a value that is stored in that variable. Now, if you want to get a value that is stored in that variable, you are going to use the variable name. And when you use the variable name, you'll say cout, and then you write the name of the variable. You say num. Then this will give you the value. This will give you the value 5. It's supposed to give you 5 because that's what's stored in 5. Also, if you have a pointer, you can still get the value that is stored at that address. You can get the value that is stored at that address pointer. So how do you do that? If you use a pointer, you're still going to say cout, but then you're going to use this operator and the pointer name, because now this operator is called a dereference operator. That's just its name. It's a dereference operator. But what it does is it's going to get to the value that is stored at that address. So if you just say cout ptr, the output will be the address, not the value that is at that address. So the output will be ox, given our example, will be oxe6. But if you want the value 5, then you will have to, if you want the value 5, then you'll have to use a dereference operator. So this will get to the value that is stored at that address. Now this is simply what we are explaining down here. We are saying so PTR, let me zoom in the board so that this can come closer so we can look at it. So we are saying, so PTR, which is what we have here, this asterisk PTR, which is a dereference operator. I don't know if you can be able to see the dereference operator, but it is up here. So we are saying that, and then the name of the pointer. So this is going to give you a value stored at the address. So in this example here, we stored 10, right? Meaning at that address there is 10 stored. So if you want to get the value, and here we store the value 10 here, and in here we say we give this pointer the address of X, meaning we have now a pointer and a name for the same value. So now if you want to get that value, you can either use the name of that variable or you can use the pointer. And if you use the pointer, you have to use an asterisk to get the value that is stored there. And since in our variable X we stored 10, if we do this, then the value that we get was 10. So now the question is, why do we need pointers? Why do we have to learn pointers? So pointers are important. We need them to directly access and modify memory. So if you use pointers, it's very fast. Pointers are very fast because you're working with memory. You'll see we're going to directly access and modify memory. You can store something at the location just using an address without using the name of that variable. You can also change that value without using the name, only using an address. So it's faster when you use pointers. So also we're going to need them in order to allow functions to modify variables outside themselves. So there's this thing when you're working with functions, you're going to do functions. When you're working with functions, if you change values inside a function, all those changes, they are only local to that function. When you get out of that function, for example, let's say you want to swap a string, you want to reverse a string, and the string is stored outside of that function. You reverse it inside of that function. Once you get out that function, the changes, they only remain in the function. When you get out of the function, those changes are no longer there, meaning the string is not reversed, it remains the same. So I'm just stating out these things so that you learn the importance of understanding why pointers. You need to understand pointers because there are a lot of things that you are going to do with pointers, even if you may not immediately understand them, but they are very important. They are more like the backbone of computer programming because later on we are going to work with them to work with dynamic memory allocation. There's a time when you're able to declare a variable, but later on you may need to reserve memory while the program is running. So before the program runs, you normally declare variable, meaning you're reserving memory. But there's a time when we'll need to reserve memory while the program is already running. We need now to reserve memory while the program is already running. Now, that's what we call dynamic memory allocation. And we can only do that using pointers, because we can't declare variables, because when you declare variable, you have to state the data type, and you do that while you are coding. But as the program runs, you can't do that. But if you need memory, then you'll need to dynamically allocate memory. These are the things that we are going to do. Also, to handle arrays, we use pointers a lot when we handle arrays. You'll see operations with arrays on arrays was going to be much more easier if you understand pointers. We also use them to handle strings and complex data structures. Complex data structures, this one we'll do in third year. You'll see we're going to, no, not even in third year. In object-oriented programming, you'll see we're going to start with a linked list, which is a memory, which is a data structure. It's a container that we're going to use to store data that heavily relies on pointers. So you really need to understand pointers. Now, I was just touching on that so that you see how important pointers are. A lot of people often realize this late, and when it's too late, well, unfortunately, there's nothing we can do. So you'll have to go back and understand the pointers from the beginning. So you can do yourself justice and understand them now. Now, declaring and using pointers. Now we have discussed what pointers are. We made an example. We also mentioned why we need pointers. We showed where we are going to need pointers, and yeah. Now we let's declare a pointer. We have already covered that. So when you declare a pointer, you have to specify the data type. This is just a data type of what kind of a variable, or what value is stored in that memory. Is it an integer? Is it a float? Is it an is it a double? So if you want to point to a memory that's going to hold a float, then you'll have to define your pointer as a float. If you want to point to a memory that is going to hold an integer, then you have to define your pointer as an int. So here we have one that is going to point to a character. So we use the data type of a character. So when you initialize a pointer, first you'll be having a normal variable. Now that's storing a value, and when you initialize a pointer, that means you give it an address. Now there's a case where we won't have an address that we want to give yet. Let's say there will be a case where there won't be an address that we want to give yet. For example, so if for example, when we declare variables, when it doesn't have any value, we usually set it. I'm just going to make an example. Let me edit our code and show you what I'm talking about. For example, let's say we have int sum, and when the program starts, sum doesn't have any value. So we usually initialize it to 0 and say, okay, there's nothing. Okay, so it's not going to it's 0. Yeah. Now with a pointer, when a pointer is not pointing to any, it's not holding, there is no valid address that you want to store in that pointer yet. Maybe you're going to do that in the program as the program runs. So now a pointer usually would say ptr. Then we initialize it with null. Null means that this pointer is not holding any valid memory address, meaning there is no valid memory address that it is holding. It's null. That means we are yet to make it point to a memory later. If you don't set it to null, then you might get a behavior that you don't know. It might give an undetermined behavior, because you don't know, it might point anything it wants. It might point to any memory that it wants. So it's very safe that if you don't have any memory, like now, see, when we declare this pointer p, we give it an address of x. If there is nothing that you have that you want to give to this pointer that we have defined at line 4 or yet, then you have to set it to be null. But the modern C++ also allows you to use what they call null pointer. I think it's null pointer. That's going to be null ptr. It's supposed to be double L. So it uses null pointer. So this means that this is a null pointer. It's a pointer that it's not pointing to when a pointer is holding a memory address. So we usually say in computer programming, we usually say it is pointing to that memory address. We are simply saying this pointer is holding a memory address of a certain memory. Or if it's for example, if since line 2 P is going to hold an address of X, which is the address where 42 is stored. So when we talk in programming, the language that we use, we'll say P is pointing to 42 or P is pointing to X. We are simply saying P is holding an address to the variable X, or is holding an address to the value 42. So we usually say it's pointing to that value. But what we mean is that it is holding an address of that value, where that value is stored. So we usually say P is pointing to that address. So if it is not pointing to any valid address, meaning it's not holding an address of any memory in a computer, then we set it to be null or null pointer. Remember, you can use null or just null pointer. I prefer using a null pointer because it's much more clearer that you're going to see that this is a null pointer. Okay, so that's how we declare pointers. That's what we do when we declare pointers. I don't want to cover too many things with pointers because they are very important, so you need to understand, and then you will be fine. Now, dereferencing. So we said when you dereference, you access a value at an address. You access a value that is stored at a certain address. For example, here we stored 42. We stored 42 in X. Here, talking about line 1, we stored 42 in X. This is line 1. And after storing 42 in X, line 2, we store the address of X in P. So we declare P as a pointer. How do we know it's a pointer? We used an asterisk here, the star. So P is a pointer. We know it's not a normal variable, it's a pointer variable. Then we stored an address of, how do we know we have stored an address of X? Because we used this operator, which gets us an address of a variable. So it got us an address of X, then it stored it in pointer P. Then when we want to access the value that is stored at that address, that's what we call dereferencing. So we are accessing a value at an address. Now we're going to say cout, then you use the dereference operator, which is this asterisk, and the name of the pointer. Then this will give you the value 2 because that's what we stored. Yeah, we stored 42 in X, so that's why it stored at that address. You'll get 42. Simple as that. Now, lastly, we need to talk about pointer operators. So when you need to get an address of a variable, so you use this operator. It's an address of. When you want to get an address of a variable, you're going to use this operator. It's going to give you an address of a variable. So this gives the memory address of the variable. So you're going to use this operator, then followed by a variable name, then it will give you the address of that variable. Then we have the dereference operator. So this one, you're just going to go to the memory address and retrieve the value. It's going to get the value. If you use this one, it means that at that memory address, you want to get the value, not the address. So it's going to give you the value that is stored at that memory address. And here we have an example to demonstrate what we are talking about. We have line 1, we have int y equals to 7, and then we declare a pointer p. How do we know it's a pointer? This asterisk here tells us that it's a pointer, and it's a pointer of integer type because this is int declared, so it's a pointer of integer type. Why? Because we want to store an address of a variable that is storing an integer. Okay, so now we get an address of y, then we store it in P. Now, if we want to get So this one we said gives us line 4. This one we said gives us an address. So this is going to print an address of y. It's going to print an address of y, while CLP is going to print the same address because it's a pointer that is holding an address. Okay, if you want the value, then you'll have to say use the dereference operator. Now this will give you the value. So these two lines are equivalent because they're going to give you the same thing. Because you say print the address of y, then it will give you the address of y and that. So yes, that's that. That's all we have to learn about pointers for now. Pointers are just simple. They're very simple and they're very important. So you need to understand them. I'm going to stop here so that we digest them, try to understand everything that we talked about. Also to keep the video short so that you can refer to it, and so you go over it again and again and again, and you understand this concept of pointers. Again, it is very important. Make sure that you understand, you 100% understand pointers. Now let's meet again in the next class where we'll be continuing from where we stopped today.